Good afternoon, students. Welcome back to science class on the chapter force. In the previous class, we had discussed some problems related to force. Okay. Today, we shall study Newton's third law of motion or third law of motion. Okay. The first law of motion, it tells the nature of an object, which means if one object is at rest, it remains at rest only, or if one object is in motion, it remains in motion only. Okay. In the second law, so due to the application of force, using a force, we can change the positions of an object, or we can change the state of an object. We can bring objects from we can bring objects from rest to motion, or motion to rest. Clear? Or we can change the direction. So we studied everything in first and second law of motions. Okay. So now we will discuss the one of the very most important law, that is Newton's third law of motion. Okay. The sentence is very simple. To every action there is equal and opposite reaction. Okay. What is that? To every action there is an equal and opposite reaction. Rocket. Okay. Rocket, it works on the third law of motion. Gun. Okay. Gun or pistol, all are works on the Newton's third law, on the basis of Newton's third law of motion. Okay. So here the sentence says that what? To every action there is an equal and opposite reaction. For example, take one ball, just throw it to the wall. What will happen? It bounces back. Why? Because see here that ball, okay, while hitting that ball, it will apply the force on the wall. That wall also applies same amount of force on the ball. So that's why it will come back. Okay, a rocket launching. Okay, so just imagine this is a rocket. Okay, see here, at the moment here, what that gas, okay, that chemical, okay, so that gas, it will come outside with a huge amount of velocity. What is that? It will come outside with a huge amount of velocity. See here, this is the action. I will call it as action. What is action? The gas, it will see that gas is coming outside with a huge amount of force or a huge amount of velocity. Okay, then see this upper body is this rocket, so it will move forward, right? Okay, see here, this is the action, and that rocket is moving forward. That is the reaction. Okay, so here that gas which is coming outside with a huge amount of force, that is the action, and that rocket which is moving upwards, so that is the reaction. Okay, so here both are equal, both action and reaction are equal, but both are in opposite direction. Okay, this action is in this direction, then reaction is in this direction. Okay, and take one more example. Just imagine this is a river, and here one ship is there. Okay, just this is a ship. Okay, so one person is standing. Okay, see this is a land. Okay, this is water and this is land. So now the person, he will jump from water to the land. So what will happen? Okay, see, when he jumps from water to land, so what about this ship? In which direction it will move? Okay, see, this person is jumping in this direction, then what about this ship? So now this ship is moving in this direction. Okay, here also action and reactions takes place. Okay, the man who is jumping from water to land, so this is the action, and this boat, okay, which is moving in this direction, this is the reaction. Okay, so here also both action and reaction are same, but they are in opposite reaction. And take one more example, while walking. Okay, see, we will push the ground backwards, right? Okay, we are pushing, that is the action, means we are applying force on the ground. Okay, see how much force will apply on that ground. The same amount of force that ground it will apply force on us. Okay, so we are applying a force on the ground. That is the action. The same amount of force you will get from that ground. So that's why you can see you are able to move forward. So that is the reaction. Okay, you are pushing, you are applying a force, means while walking you will push that ground, right? Okay, that is the action, and you are moving forward. That is the reaction. Okay, here also both action and reaction are same, but they are in opposite. They are in opposite direction. Okay, see here. See, if you take one small stone, just to throw it on a wall, that stone it will apply a force on the wall. Correct? The same amount of force, that wall also it will apply same amount of force on that stone. Okay, so here also action and reaction are same, but they are in opposite direction. Okay, so this is the Newton's third law of motion. So what it states? It states that to every action there is opposite and equal reaction. I mean always. Okay. Next, take one gun example. Take one gun example. Okay, see, just imagine this is a gun. See, when you press this button, that bullet it will come with a huge amount of force, right? That bullet it will move in this direction. Clear? Then what about this gun? This gun it recoils back, right? Which means this gun it will move in this direction, right? Moving means what? Just once it will come like this. Okay, when you fire, just when this is the gun, it will come like this. Okay, so that bullet is moving in this direction. That is the action, and this gun it will move in this direction, right? So that is the reaction. See, that bullet while leaving, it will apply a force. It will apply some amount of force on that gun. Also applies same amount of force on that bullet. Okay, but that bullet it is moving with huge amount of force. But the gun it is also moving with some huge amount of force. But that bullet it will cover more distance. But then it will cover less distance. Why? Because there is due to the change in the mass. Gram is very less, right? So bullet is very less, right? It is in the gram, but it has maybe 1 kg or 2 kg, like that. Okay. See, the acceleration may be different. I will throw that. See, you are throwing some amount of force on the wall. Okay. See, while going, the acceleration is not equal after that stone coming back. So both are not equal. Okay, acceleration may be different, but the stone, say, while throwing that stone, it will apply some amount of force. That amount of force which is equal to the that force from that wall to the stone. So here both are same. Okay, the application of force stone to wall and wall to stone. Both the forces are same. There is only change in the acceleration. That is due to the changes in the masses of the objects. Here, wall it has more mass than stone, right? Okay. So this I think we have so many examples. Okay, for Newton's third law of motion. And take one balloon example. Just to blow that balloon. Okay. So just release it. What will happen? So it will move, right? Why it is moving? See, when you leave that balloon, see here that air, it will come with some force, right? It will come outside. Okay, that is the action. And this balloon is moving in one direction, right? That is the reaction. Okay. Next. Yes. Okay, so hope you understood what is Newton's third law of motion. Okay, so next to move to one more important derivation. Okay, one more important concept, that is of momentum. Okay, conservation of momentum. So I think already you know, already have studied, right? Some conservation law of conservation of energy in the previous year. Okay, so what it states that law of conservation of energy can neither be created nor destroyed, but we can transform one form to another form. So here also say what, when do we say that the momentum is conserved? Okay, when we say that the momentum is conserved, see, you know, we can say that the momentum is conserved when means if the initial momentum is equal to the final momentum. When initial momentum is equal to the final momentum, then we can say that momentum is conserved. Okay, see this one example. Now take two balls. Okay, this is A and this is B. Okay, see, just imagine both are moving. Now see, it is moving with see its velocity is greater than object B. Both are moving in a straight line. Okay, so both are moving in a straight line. So now the speed of object A is greater than the speed of the object B. Okay, now both, see, after some time definitely both will collide each other because it is its velocity is more. Okay, now if you calculate momentum of this object and momentum of this object, if we calculate momentum of these two objects, okay, here you will get one value, so we call it as initial momentum. Initial momentum. Now see, this is just this is during collision. During collision. During collision, say after some time both will collide each other, right? Okay, this is during collision. So after collision, once again both will separate, right? Both will separate like this. Okay, A and B. Both will separate each other. Okay, so here maybe see during collision maybe its velocity maybe decreases and its velocity maybe increases, whatever it is. Okay, after collision, its velocity maybe it changes or decreases, maybe velocity of this object increases, whatever it is. Okay, but here also if you take the momentum of this object plus momentum of this object, here also you will get some answer, right? So then here what, see what you will get here, the same value you will get here also. Okay, so before collision and after collision, the initial momentum is equal to the final momentum. Then we can say that momentum is conserved. So clear, right? When initial momentum is equal to the final momentum, then we can say that momentum is conserved. Okay, so here initial momentum is equal to the final momentum. You know, just to take one example of a bus and car, just imagine. See, this is car. Okay, just imagine this is bus. You know, the car is moving in this direction, the bus is moving in this direction. Okay, just imagine the car is moving with the car, its speed is greater than the bus. Okay, say it's moving with the 80 km per hour, and say this is 40 km per hour. Okay, now see, just imagine both are traveling, okay, in the opposite direction. Okay, now I will take see how much time, while see here you have to consider time also. Why? Because see, now this is before collision. Okay, see, just imagine before I take the time, say 3 seconds. I'll take the time 3 seconds before collision. I'll take the time 3 seconds before collision. Before 3 seconds, I am calculating the momentum of the car and bus. Okay, are you getting my point? I am taking the time is equal to 3 seconds. That 3 seconds is just before the collision, and then I will calculate momentum of this object and momentum of this object. Okay, I will add, so I will get the initial momentum, say some value. Now just imagine both collide with each other. Okay, both collide with each other. What will happen after collision? Maybe see the speed of this car also reduces, and the speed of this bus also reduces little bit. We don't know. Okay. Then after 3 seconds, see after collision, and after 3 seconds, if you take the momentum of this car and bus, if you add, then also you will get the same answer. So then we can say that momentum is conserved. So clear? So before accident, after accident, okay, if you take the momentum of both bus and car, okay. So here you will get initial momentum, you will get the same answer for final momentum. Okay, so then we can say that momentum is conserved. Okay, so now here we should prove mathematically. Okay, theoretically is correct, right? But we need mathematically, we should show mathematically what the initial momentum is equal to the final momentum. Okay, so this is also one very important derivation. This is also very important derivation. Okay, for 4 or 5 marks questions. So now, take two objects. I'll take this as A on A. Okay. Then after collision, once again both will separate each other, right? This is A and B. Mass remains the same. Okay. But what about velocity? So definitely velocity changes. Okay. So I will take the velocity of this object as V1 and this object as V2. Now first calculate the initial momentum of these two objects. So I will calculate here. First I'll take momentum of this object as P1. P1, what is that? M1 into U1, and P1 equal to M2 into U2. I learned. So initial momentum is equals to M1 U1 plus M2 U2. So this is the total initial momentum before collision. Then what is total final momentum? Here also same, right? Final momentum, that is M1 into V1, M1 plus M2 V2. Clear, right? How to calculate momentum here? Momentum is, what is the formula? P is equals to M into V. Mass into velocity. What is the velocity here? V. And what is the mass? M1. So that's why M1 V1. Then here also mass into, what is the velocity here? V2. What is the mass? M2. So that's why M2 into V2. Clear? Okay, see here. So now we should say that statement says that what? This initial momentum is equal to the final momentum. That is M1 U1 plus M2 U2, which is equal to M1 V1 plus M2 V2. So now our work is to prove this initial momentum is equal to final momentum. Okay, so mathematically we should prove this one. Initial momentum is equal to final momentum. Final momentum. Okay. Yes. So now how to prove this one? How to start? Already we have studied some two derivations, right? Equations of motion and expression for force. Okay. Now third one, we should prove that initial momentum is equals to final momentum. But how to start? Yes, how to start? Please put your answers in your comment box. Okay. So here we need two objects. So that's why. So first our statement it should begin with consider two objects like that, and its mass is m1 and take its moving with initial velocity u1, and one more object its mass is m and it is also moving with initial velocity u. Okay. So like that, just please put your answer in the comment box. Quick, how to start the derivation? How to start the derivation? Okay, see, let's begin. So consider a body. Say consider a body A. Consider a body A. It has mass m1. It has mass m1, and it is moving with initial velocity. And it is moving with, sorry, it has mass m1, and it is moving with initial velocity u1. And it is moving with initial velocity u1. Okay. Now consider one more body. Consider one more body B, and its mass is m2, and it is also moving with initial velocity u. Okay, see, both are moving in the same direction, and here, so we should consider object A, which is its velocity is greater than the object B. Both are moving, means its velocity is less. Okay, so after some time, what will happen? After t seconds, after t seconds means after some time. Okay, I don't know, maybe 1 second, 2 seconds, or 50 seconds, whatever it is, I take it as t. After t seconds, what will happen? Both will collide each other. Both will collide each other. So during collision, what will happen? During collision, so here this object A, okay, object A, I will take it as Fa. Okay, now object A, it applies force on object B, so that is Fa. So now, then what about object B? So it will also apply the same amount of force, right? It will also apply same amount of force on object A. Okay, so I'll take it as Fb. Okay, now see here, both are moving in this direction. Both are moving in this direction. Okay, so this object is applying force in this direction. So if we calculate the force, definitely we will get a positive. Okay, now see, both are moving in this direction, but this object, it is applying force on this object. Then if you calculate the force, so here you will get a negative, right? Why? Because see here, these two objects are in this direction. Here the force from this object. Okay, so clear the meaning of negative. So here, this force which is in the against the direction of the motion of the objects, means it is in opposite direction. So that's why here we should take minus Fb. This force, we should take this force as negative, and we should take this force as positive. Why? Because the application of the force and the direction of the motion of the objects both are in same direction. But in this case, see, direction, the motion of the directions of the objects in one direction, and force is in another direction, means it is in opposite direction. So that's why we should take minus F. Okay, now, so after collision, so this is before collision, this is before collision, this is during collision, during collision, and this is after collision. After collision. So what will happen? So mass remains same, right? m1, m2. What your velocity changes? I will take this. Its velocity changes to v1, and this is v2. Okay. So now first calculate the initial momentum. First calculate the initial. So already we know. So our work is to prove that initial momentum equal to final momentum, right? So now how to start? Okay, so introduction already given. So here we should use this concept. We should prove. What is that? Our work is to prove m1 u1 m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. Okay, yes. So what's the next step? Yes. What's the next step? No one is responding. Okay. Yes. See here. So now see here. Calculate this force Fa. Now calculate the force. How to calculate force? We have formula, right? F is equals to mass into acceleration. Okay. What is the mass? What is the mass? See here, you know, for example, this is see one object. Okay, I will apply force. You calculate the force applied, that applied force. So here you will consider mass of this marker or my hand. So see, I am applying a force, right? So here you should consider mass of this marker, not my hand. Clear? So here you should take the mass of this marker and acceleration of this marker. So now here, see here, this object A, which is applying the force on B, right? Then here you should take mass of the B and the acceleration of object B only. Okay? So now I will calculate force Fa is equals to mass into acceleration. Mass into acceleration. So what is the mass? Mass is m1. What is the acceleration? Its velocity changed from u to its acceleration. Its velocity changed from u2 to right u2 to v1. So that's why in a time t, that is v2 minus u2 divided by t. Okay. So m into v2 minus u2 divided by t. So force is equals to mass into acceleration, that is m1 into v2 minus u2 divided by t. Sorry, m1 not, it's m2, right? Sorry, it's m2. Why? Because here this object which is applying force on object B, right? So here we should consider mass of this object, okay, and acceleration of this object only. So mass of this object is m2 and acceleration is what? Change in velocity. Here the velocity of this object changes from u2 to v2 in a time t. So that's why t. Okay. So now we got Fa is equals to m2 into v2 minus u2 divided by t. Then next, calculate Fb. Okay. Calculate the force Fb. Calculate the force Fb. Okay. So what is the formula? That is mass into acceleration. Clear? What is the mass? See now, see here, this object B, okay, which applies force on object A, right? So now in this case, we should consider mass of this object and acceleration of this object. Okay. So what is the mass of this object A? That is m1. And what is the acceleration? Acceleration means change in velocity. Here, velocity changed from u1 to v1, u1 to v1 in a time t. So acceleration is v1 minus u1 divided by t. Okay. So Fb is equals to, so I will call this equation as 1 and this equation as 2. Okay. Yes. What is the next step? Just think. See, if you are poor in mathematics, then it is very difficult to study physics. If you want to study physics, you should know basic mathematics. Okay. What's the next step? You know, according to Newton's third law, what? See here, see these two objects collide with each other. So now this marker, see this marker, it applies force on this marker and this marker. So it is also applies force on this marker, right? So here the force from this marker and force from this marker, so both forces are equal, but both the forces are in opposite direction. So this is according to the Newton's third law. What it says, to every action there is an equal and opposite reaction. Clear? Always there is an equal and opposite reaction. Just imagine this marker, see, it will apply 2 Newton force on this marker. So this marker also, it will also apply 2 Newton force on this marker. Okay. Clear? So here the acceleration masses may different, whatever, but force from this marker and the force from this marker both are same and they are in opposite direction. Okay. So that's why according to third law of motion, we can say that Fa is equal to minus Fb. Why it is minus? This force in the opposite direction, but both are equal. The forces are equal, but this force is in opposite direction. So that's why here we should put this negative symbol. Okay. Now substitute here. What is FA? FA is, I'll write here, M2 into V2 minus U2 divided by T is equals to minus into, first keep that minus outside, okay? Later we can multiply. So F will M1 into V1 minus U1 divided by T. Clear? Okay, so now first multiply here M2 here. So when you multiply M2 into V2, we will get M2 V2, then minus M2 U2. Okay, then whole divided by T. Clear? Next, key minus outside, that is M1 V1 minus M1 U1 divided by T. M1 V1 minus M1 V1 minus M1 U1. Okay. Now multiply this minus symbol. Okay. So here we get M2 V2 minus M2 U2 divided by T is equals to minus M1 V1 plus M1 U1. Plus into minus into plus minus, minus into minus plus. So divided by T. Okay, so now just observe here, this T get cancelled, right? So if you bring here, now it is in the numerator, what will happen? You bring, it will go to numerator, right? It goes to numerator, so that's why T get cancelled. Okay, next. So next step, M2 V2 minus M2 U2 is equals to minus M1 V1 plus M1 U1. Okay, so now take this minus this side and this minus this side. Okay, so M2 V2, I'll bring this side. See here, now it is minus. What happens when you bring to this side? It becomes plus, right? So plus M1 V1 is equals to take minus M2 to this side. Here plus, what happens to bring this side? That is plus, right? So M2 U2 plus M1 U1. Just observe this equation and this equation. Okay, M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. So M2 V2 plus M1 V1 equal to M2 U2 plus M1 U1. So proved, right? Hence proved. Okay. So here, so what is the meaning of this equation? So it says that initial momentum is equal to the final momentum. So this is the initial. So this is final momentum, right? Final momentum is equal to the initial momentum. Both are same. Initial momentum equal to final momentum, or final momentum equal to initial momentum. Okay. So this is proved mathematically. So when do you say that momentum is when do you say that the momentum is conserved? So when initial momentum is equal to the final momentum, then we can say that momentum of that system or momentum of the objects are conserved. So clear? So today I will stop here. So tomorrow we will discuss some problems on the using this formula. Okay. Thank you.